Now, this is what we are going to discuss in today's class. Introduction to Faraday's laws, and the topic will also discuss about the AC generator. This happens to be a part of the electromagnetism, right? So let us start the session. Before starting the session, I would request all of you to join the Telegram channel of Unacademy, ICSE and ISC board. This happens to be the generalized link of the channel. I mean, if you are joining this Telegram group, you will be updated with all the notifications from Unacademy regarding ICSE and ISC boards. And this happens to be the Telegram channel for physics only. Fine. And here, what you'll get to know, you'll be updated with all my notifications, all my session timings, whenever I'll be coming live. And most importantly, Unacademy has come up with a very unique and a new feature that they are calling open house. So you'll be updated with all the upcoming open house sessions as well, right? So good to go. I hope and wish that all of you will join this channel. Now, before I start the session, I would like to inform you, I would like to explain you some very important and unique features that Unacademy is offering in its free special classes. See, you can clearly see in the slide, you have the facility to interact live with the students, right? You have that facility of interacting with these, the students can interact with the educator live, right? I mean, in the message box, in the chat box, you can drop in your queries, and in case you're not able to understand certain concept, you have the facility for asking the questions in the ask question tab as well, right? So this again is an added advantage. Cool. And in our special classes, we conduct a number of live polls. Why am I saying that these polls are important? Once you are attending these polls, you'll be able to check your performance. I mean, in the poll board, you'll get to know how you're performing in a particular session, right? Now, very important thing, these are the timings for my special classes. I'm having a special classes on 7th, 8th, 10th and 12th Feb. These are the topics that I'm going to discuss in the special class. The class on 7th of Feb, that is Monday, is going to be a very, very important class. Why am I saying this? Because in that particular class, we'll be discussing the sample question paper that is provided by ICSE Council. I mean, they have provided a question, and we'll be elaborately discussing all the concepts of the question. An elaborative solution will be provided to all the concerned students, right? So don't miss that class. In case you haven't subscribed, if in case you haven't enrolled for that class, this is the right time to go about it. Okay. And don't forget to follow us on Telegram. Just connect with us so that you get updated with all the upcoming sessions. Now let's start the session that we were supposed to do. The session will discuss electromagnetism and precisely Faraday's law. See, in order to understand what these laws say, it is very important to decode the back end story. And at the back end, Faraday performed an experiment. The result of these experiments are popularly known as Faraday's laws of electromagnetic induction. So in order to decode those laws, it is very important to understand what that experiment says, right? So let's see what it says. See, we already know that a current carrying conductor can produce a magnetic field. And how did we get to know? I mean, Ørsted performed an experiment, and the results of that experiment concluded that a current carrying conductor can indeed produce a magnetic field. And how can we judge, how can we check the strength of that magnetic field? I mean, we have all the facility to increase the current and increase the magnitude of the field. Yes. And how did we notice that there was a field? We had a needle, and we saw that when the needle was placed in the vicinity of that current carrying conductor, it was deflected, right? So that was the case. Cool. Now what Faraday thought? Faraday thought, if a current carrying conductor can produce a magnetic field, why can't we have a reverse phenomena? I mean, there has to be a phenomena through which a current can be induced through magnetic field, right? This was the core concept. This was the thought which compelled him to go about that experiment. So whatever results he got from the experiment he performed, those results are actually called Faraday's laws of electromagnetic induction, right? The laws are nothing but the result that he got through his experiments. Fine, I hope you have understood this. Yes. Now see, let us check what the experiment was and how did he get those results. So this picture depicts the exact experiment that Faraday performed. I have taken this pic so that you can, kind of pictorially understand how things change. See, just try and analyze. Here you can see that the magnet is at rest and the coil is at rest. In all the cases, I have taken coil at rest. You can clearly see that the coil is not moving in any of the cases. Yes? But in case 1, you can see that the magnet is also stationary. So, what he observed, when a stationary magnet was placed near a current carrying coil, he observed that there was no deflection in the galvanometer. This is a galvanometer. And what he observed was that there was no deflection in the galvanometer, right? And what was the reason? Obviously, galvanometer has having no deflection, which clearly means that there is no current flowing. So the very first conclusion that he had, I mean, if there is no deflection, there is no current. And why isn't there a deflection? Because there is no relative motion between the magnet and the coil. Now what he did, in case 2, what he did, he started moving the magnet. Now, the coil was still stationary. The only thing that was moving was the magnet. What he observed, as soon as he brought the north pole of the magnet towards the coil, he observed that there was a deflection in the galvanometer. You can clearly see in the pic that the galvanometer is showing a deflection. And as soon as the galvanometer shows deflection, we should rather conclude that there is indeed a current flowing in the circuit, right? Now what he did, he just reversed the phenomena. Now what he did, instead of moving the magnet towards the coil, he started taking the magnet away from the coil, right? What he did, instead of taking the magnet towards the coil, he started taking the magnet away from the coil with the same settings. I mean, the setting was not disturbed. What I mean to say when I'm talking about setting, I mean, still the north pole of the magnet was facing towards the coil. Now what he observed, there was still a deflection in the coil, but this time around the deflection was in opposite direction. Okay, there was again a deflection, but this time around the deflection was in opposite direction. Fine. Now what he did, he just changed the settings. He just reversed the direction of the magnet, and then again he brought the magnet close to the coil. Again there was a deflection. You can see in this particular case, again there is a deflection, but just see the deflection direction. Here this was the direction, but here this is the direction. And what does this difference in the direction signify? See, when there is a difference in the direction, he concluded that okay, there is indeed a current, an induced current, but this time around the current is induced in an opposite direction. Yes, current is indeed induced but in opposite direction, right? So what he concluded, whatever he concluded from these particular observations, those conclusions are actually known as Faraday's laws of electromagnetic induction, right? Now let's see the technical part. Now if I have to define what electromagnetic induction is, how will I define it? I would rather say electromagnetic induction is the process where an EMF is induced in a coil due to the change in the magnetic flux. Now let us decode this situation, what this situation depicts. Now see, this is a coil, right? This is a coil. This is a magnet. Here what we have done is, in case A, you can clearly see that the coil is moving, but the magnet is stationary. Yes? Now, I have a magnet. Let us suppose this is the magnet. You can see in the pic, this is the magnet and this is a coil. What I am doing, I am moving the coil towards the magnet. Now, every magnet has its sets of magnetic lines of forces, and we know that magnetic lines of forces, they originate from the north pole and they move towards the south pole, right? Now, initially, let us suppose initially when there was no magnetic flux passing through the coil, I mean to say when the coil and the magnets were at a very large distance, in that case, there won't be any magnetic flux passing through the coil. Yes or no? I mean, if you've understood, you can drop a message at the chat box. That's good to go. You can clearly see initially when the coil was at a very large distance from the magnet, none of the magnetic lines of the magnet were passing from the coil, right? And in that case, you can see that there is no deflection in the coil. The galvanometer is reading 0. I mean, it is not deflected at all. Now, when the coil is brought close to the magnet, now what happens? Few magnetic lines of forces of the magnet, they actually start crossing the coil. Now, initially, none of the magnetic field lines were crossing the coil. But now you can clearly see that few magnetic lines are crossing the coil. I mean, initially, if I say that the magnetic field lines were 0, initially, finally I can clearly see that magnetic field lines is having few values. I mean, let us say 8 magnetic field lines are crossing. Now see, we have to understand what do these magnetic field lines signify. See, magnetic field lines signify nothing but the magnetic flux, right? Magnetic field lines signify nothing but the magnetic flux. See, magnetic flux is the measure of the magnetic field lines passing through a closed coil. I mean, why am I saying closed coil? Because if the coil will be open, no current will flow in the circuit. Okay, I've taken this pic from your textbook and I hope you've understood how and why a magnetic flux is changing and what are the the reactions, what are the observations. In figure A, you can clearly see that there is no deflection in the galvanometer. Why? Because there were no magnetic field lines of the magnet crossing the coil. Later on, you can see that few magnetic field lines of the magnet were actually crossing the coil. Now, initially, if phi I is 0, what is phi f? Phi f is say 8. I mean, I'm not quantizing it, but just in order to make you understand, let us say that phi f is 8, right? Now, phi I is 0, phi f is 8. Is there any change in the flux? Yes, there is a change in the flux. 8 minus 0 is 8. See, don't be confused with 8 and 0. I am just giving it a number so that you guys understand that, the flux lines are changing. And because of this changed flux lines, an EMF is induced and a current is flowing. See, if a galvanometer is showing a deflection, that means 110% there is some current, because galvanometer is basically used to detect the current. We have discussed this in previous sessions as well. The basic difference between galvanometer and ammeter. Ammeter gives you the magnitude of the current. It helps you to understand the amount of current. Okay, but galvanometer will only detect the presence of current. Yes, so far so good. I hope you're getting my point. Now there is one other constraint as well. I mean, it is not necessary that you are moving magnet only or you are moving coil only. Here in this particular, I have taken two contradictory examples so that all my students get to know that in both the conditions the motion is possible. The core concept is that the flux passing through the coil should change. It is irrelevant whether the magnet is moving, whether the coil is moving, or maybe both are moving. That is absolutely irrelevant. So you don't have to bother about the movement of the magnet and the coil. There has to be a relative movement, that is important. But which is moving, which is not, that doesn't matter. They have asked the question once in your ICSE board examinations. Okay, I mean, what if the magnet is stationary and the coil is moving? Nothing will happen. I mean, nothing different will rather happen. Again, if there is a change in the flux, an EMF will be induced and a current will flow in the circuit. So in all possibility, there has to be a relative motion. I mean, either the coil can move or the magnet can move. Yes, I hope you have understood. Good to go so far. Okay. Now, if I talk about the conversion of the energy, you can clearly see that the slide says that in EMI is the short form for electromagnetic induction, the mechanical energy to move the coil to change the magnetic flux is converted into electrical energy. See, what is the output part? What actually am I getting? I am getting current. And what is current? Current is a form of electrical energy. So my output is rather electrical energy. And how am I getting this electrical energy? I'm getting this electrical energy through the relative motion, right? Be very specific. I mean, I don't want my students to say motion. Due to the relative motion. Why relative motion? Because motion can be on either sides, right? And because of that relative motion, an EMF is induced. And we know, we have studied in current electricity, if EMF is induced, current will 110% flow in the circuit. Yes, good to go. I hope you have understood what I'm trying to convey. Excuse me. Okay, now another important question. See, we have to study the application part. That is okay that a current is induced, but we have to find the direction of the induced current as well. I mean, if you're not able to find the direction, it's of no use, because ultimately we have to see the working of an AC generator. That is our main concern. So what happens? The direction is determined through Fleming's right hand rule. Okay, Fleming's right hand rule. Fleming's right hand rule is used to determine the direction. And what does this rule say? See, if I stretch, this is the basic thing. If I stretch my forefinger, middle finger, and thumb in such a way that all three are mutually perpendicular to each other, this is how we perceive. You can see all three fingers are mutually perpendicular to each other. Yes, I mean, thumb, the forefinger, and the middle finger, all three are mutually perpendicular. You can clearly see. Now, if the thumb represents the motion of the conductor, the forefinger represents the direction of the magnetic field, then this middle finger will tell you the direction of the induced current. Fine. See, a number of students get confused. Movement of conductor, what does it mean? I mean, why will a conductor move? The very first thing that should strike your mind, anything in the universe moves if it is acted upon by a force. So rather, instead of writing movement of conductor, you can perceive it as force as well. I mean, indirectly, this thumb is telling you the direction of the force. The forefinger is telling you about the direction of the magnetic field. And this middle finger is telling you about the direction of the induced current. And this is what we were supposed to determine. Okay. See, the outcome was an induced current and we were supposed to determine this induced current. So I hope this law is pretty much clear to everyone. Yes. Okay. Now, let me brief all my students about this Unacademy Prodigy test. This test is for class 7 to 12th learners, and the best part is the enrollment is absolutely free. The test is scheduled for 4 dates: Jan 23, 29, Feb 6 and Feb 13. The 2 dates are already gone. The next is Feb 6. I mean, tomorrow you will be having a test, and the timings are 12 to 1, right? And why should you go for this test? Because you'll get a chance to win exciting prizes. I mean, in the subsequent slides, I'll tell you what prizes can you win. See, there is no harm in appearing in this Unacademy Prodigy test. Why am I saying this? Because, see, first of all, the enrollment is absolutely free. Second, you get to check your preparation. You get to have a check on your preparation, on your mental ability, and the most important thing, you have a chance to win prizes as well. The prizes might be in terms of your college scholarships. Okay, so you should rather go with it. And this is the schedule for the tests. Okay, I mean, this happens to be the test schedule. Feb 6, this is the schedule for tomorrow's test. You can see for class 7 to 8 the test will start at 12 noon. For class 9 to 10, that again the test will start at 12 noon. And then these are the timings for subsequent sessions. I mean, you have a schedule for class 11, for class 12 JE, and class 12 NEET, the dropouts one. So you should rather go with it. It's a win-win situation for everyone involved. Okay, and these are the prizes that you can win. Okay, see, rank 1, you get a chance to win a MacBook Air. Rank 2 and 3, iPhone. Rank 4 and 5, iPads. Amazon Echo Dot, rank 6 to 40, and rank 41 to 100, you'll get a chance to win Amazon vouchers. Okay, and this is how the rank will be decided. You can clearly see 100%, 75, 50, 25, 15. So in all possibility, you have a chance to win. You should rather appear for the test. Okay, now these are the batches that these are the upcoming batches for class 9th and 10th where I'm teaching the physics batches. One is the champions batch. In champions batch, the delivery is in English. I mean, this is for all the students who want the content to be delivered in English. The best part is you can subscribe for class 10, then you can get the subscription for 11 to 12 absolutely free. Then we have another batch, champions batch. This is for class 9th students. Again, the mode of delivery is English. Okay, the same offer applies here also. If you're subscribing for 10th, 9th, you'll be getting 11th, 12th absolutely free. Okay, now let's see how does an AC generator work. The very first thing is, what does an AC generator do? An AC generator converts the mechanical energy into electrical energy. And what is the working principle? The working principle is basically electromagnetic induction. So an AC generator, the very first question that should come in your mind, or maybe a very important question for your board exams rather, which of the following is the working principle of AC generator? If magnetic effect of current, electric effect of current, electromagnetic induction, XYZ. So the correct option is principle of electromagnetic induction. Okay. See, I have taken a very generic diagram of an AC generator that can help you have a very basic idea of how a generator will work. See what we have. Let me move on to the construction part. We have strong horseshoe magnet to create strong magnetic field. See, these are magnets which create a very strong magnetic field. Second, we have an armature coil ABCD which has a large number of turns of insulated wires. Why do we have a large number of turns? So that maximum magnetic flux is contained, you get maximum change in the flux. So this happens to be your armature coil, right? Then you have got two coaxial slip rings. Just remember this is the basic difference between a DC motor and an AC generator. In DC motor, a single ring is split into two parts and we call it a split ring. Don't be confused. A number of students, they're very confused with split rings and slip rings. See, split rings are in DC motor and slip rings are in AC generator. And the best part is the slip rings are coaxial. I mean, both the axes coincide. Okay. Yes. I hope you have understood this. Now, then you have got two brushes. The brushes are fixed, right? These are two brushes. The brushes are fixed. I mean, you can have a different orientation as well. That doesn't matter. In both the cases, the working will not change. Okay. So you've got two brushes against which these rings, move. Okay. So let's see how does it function. For that, you have to kind of imagine. Just see, it's a very, very, very interesting process. Let us suppose this is the armature. I hope you can see this is the armature. And this armature is placed between two very strong electromagnets. This armature is placed between two very strong electromagnets. You can clearly see in this picture. This is the north pole, this is the south pole. That means a very strong magnetic field exists here. Yes, fine. And your armature is connected to this axle. I mean, we have to provide mechanical energy. We'll be converting the same mechanical energy. This happens to be your axle. We'll be converting the same mechanical energy. Hi Krish, how are you? Long time. We'll be converting the same mechanical energy into electrical energy. So how does it work? What we do, we start with this particular position. I mean, you can start with any position. What you have to focus on is the change in the magnetic flux. Just remember one thing, most of the students get this incorrect. In AC generator, you have to focus on the change in the magnetic flux, not anything else. So let's see what happens. Initially my coil was like this, okay, and a very strong magnetic field was created. I mean, the magnetic field lines were crossing this coil this way, right? So far so good. And what I did, I created a mechanical force. I mean, I moved this coil. Let us suppose I moved this coil this way, right? I have moved this coil this way. Now what will happen? When the coil was under this condition, let us suppose the I have taken 5 flux lines. I mean, let us suppose my 5 fingers are 5 flux lines. So I have taken 5 flux lines. They are crossing the flux. I mean, they are crossing the coil. You can clearly see. What I have done is I have mechanically rotated the coil. I mean, as soon as I start rotating the coil, you will get to see like the number of flux lines that were crossing has started reducing. I mean, initially when the surface was like this, all 5 magnetic field lines were crossing. But now as I'm moving the surface, few of the magnetic field lines will be moving out. I mean, they will not be crossing the armature point, the armature board. Now see what happens. When we change the orientation, the number of flux lines decreases. But we are not bothered about decrease or increase. We are bothered about the change. And we can clearly see that as the coil is rotating, the magnetic flux lines are changing. If the magnetic flux lines are changing, it means that the magnetic field is also changing. Yes? Clear? You're getting this point? And what does this electromagnetic induction say? It says if the flux changes, an EMF is induced, due to which a current will flow in the circuit from this to this position. I mean, here all the 5 magnetic field lines were crossing. Here no magnetic field line is crossing. So the change in the flux is maximum. When the change in the flux is maximum, you can clearly conclude that okay, now maximum EMF will be induced and a very high current will flow, and that is what I wanted. But the question is, how will I determine the direction of the current? That is what we are bothered about. So how will I determine? See, it's very interesting and most of the students are confused in this part. When the coil was like this and started moving this way, you can clearly see, if I take this particular arm, I've marked it as AB. I've marked it as AB. What I can say is this AB is moving up. You know, the AB was initially here. Now AB is moving that way. That means AB is moving up. So what I have to do is I have to again consider Fleming's right hand rule. What is the direction of the force? The force is up. You know, the force is up. And what is the direction of the magnetic field? The magnetic field is from north to south. You can clearly see north to south. So what will be the direction of the induced current? The direction of the induced current will be A, B, C, D. So this will be the direction of the induced current. See, the direction of the current is very important. You have to understand this. Otherwise, the working is of no use. You can clearly see in the case 2, the diagram. I have marked the arrows. The arrows tell you how the current is actually flowing. Yes? You can clearly see the direction of the current. But now, once the coil is reached at this particular stage, it will not stop. I mean, it will again move. Now this AB, which was initially here, it is now here. I mean, at the top. Now this AB is at the top. But again, once it is moving, you can clearly see that the magnetic flux is again changing. So every time the flux changes, an EMF is induced, due to which a current flows in the circuit. This is how an AC generator works. Now, I have depicted this, I have taken this book diagram from your textbooks. And what does this diagram say? See, initially this dotted part means AB was like this. AB was initially this way, right? Right? When the AB was this way, maximum flux was crossing, no doubt, but the change in flux was zero. So when the change in flux was zero, the EMF was zero. See, we are not bothered about the flux, we are bothered about the changing flux. Now, as the coil was moving, the flux was changing. When the coil is at this position, the flux is maximum. You can clearly see the graph. Now, again, the flux is increasing, but again an EMF is induced, but the current is flowing in the opposite direction, and you get a sinusoidal variation. Yes, I hope you have understood. Yes, this is how the EMF is generated, and once an EMF is generated, the current will indeed flow in the circuit. Okay, now these are few very important points. If you're watching this lecture, just make a note of these points. What does these points say? The induced EMF is maximum when the magnetic flux linked with the coil reduces to zero. Yes, obviously. See, this was the initial position. Magnetic flux, maximum flux was crossing. Now zero flux is crossing, right? So this is the condition where maximum flux is changing and maximum EMF will be induced. No EMF will be induced if there is no change in the flux. And when do you get this condition? When your coil is perpendicular to the magnetic field. In this particular case, maximum flux lines are though crossing the tab, but the change is zero, so no current flows. Okay, now let me brief you about this Unacademy subscription feature. In case you're watching me on YT and you wish to take the Unacademy subscription, you should rather know the salient features. The very first part, you get to learn at the comfort of your home. I mean, there is unlimited access. You get to learn from the top educators. Okay, every fourth class, this is the best part, every fourth class is a doubt clearing session. I mean, you study the concept for 3 classes and then you get a fourth class to clear your doubts. The session covers the class module, they cover the syllabus in an extensive manner that adds advantage and that adds value to your preparation. So you should rather go with it. This is my code, KALYANLIVE. This is my YT code. Okay, you can use this code to unlock these special classes. Okay, Kalyan Live, don't forget to use this code. Once you're using this code, you will be able to unlock all these special classes. Now let's have a quick look on this Unacademy subscription plan. You can clearly see, as you move for a higher duration, the subscription value subsequently decreases. You can clearly see the subscription part. For a 48-month subscription, this is what you have to pay per month, and trust me, that's very, very commendable. Okay, this happens to be my code, KALYANLIVE. You can use this code to get the subscription. Okay, once you're using this code, you will be getting 10% discount. 10% discount on the over and above pricing. Whatever price, see, already the prices are very, very, very effective. They are very competitive as well. I mean, just look at the pricing. You have to shell only rupees 833 per month if you are opting for a 48-month subscription. Most of you would be interested in this 12-month or maybe 18-month subscription. For 12 months, per month is only 1250 rupees. I mean, that's very, very reasonable rather, right? So this again is my code. If you are new to the class, you want to watch my special classes, I have given you the details of my special classes. This is the detail of my special classes. If you want to unlock these classes, if you want to, I mean, if you wish to use, if you wish to attend any of these classes, well and good. You can attend the classes. You can download the Unacademy app. You'll get all the details there. And these are the timings. This class is going to be very important. And one more important announcement: join me on this particular channel. Join me on this particular channel because the an academy has started a very unique feature that is called open house. I'll be having an open house session in the next 5 minutes. So once you join me, you can get access to it. I mean, there we'll be discussing the basic concept of electromagnetism today. I hope you have found the content worthy enough. We would like you to subscribe the channel if you haven't subscribed it yet. You can download the PDF of this session. Don't forget to like and share. In case you're new, you haven't downloaded the app, this is the right time to download it, right? Okay, this is all from my side for today's session. In the next session, we'll be discussing transformers. In the next YT session, we'll be discussing transformers. The session is tomorrow. Just join the Telegram group and you'll be updated with each and everything. Okay. Thank you very much for the session. Hope to see